Fourth period. Hello, I hope you had a good weekend. So we're moving into some more difficult stuff. So if you have questions, please put it in the comments so I can answer for everybody. I'm happy to, just shoot out videos of specific problems that you're having trouble with from the assignments, whatever. Just let me know. I have to know in order to do it. So this is section 3 of chapter 10, and we do have an EQ. I can't remember if I've had one other times, but there is an EQ, so you have that. I will be grading notes at the end of chapter 10. I'll have a special Zoom probably on a Friday. I'll just give you 3 hours where I'll be there, and you just come on and you show me your notes. Just flip through the pages for me, and I will give you a grade. So, chords, etc. It's exciting stuff. Just so you know, this is a lot of notes. It's going to be long, so don't be afraid to just hit pause, take a break, do those problems from the homework, and then go back, however you want to do it. So here we go. So this is the first of several theorems today. It's the congruent corresponding chords. So in the same circle, or in two congruent circles, you have, oops, I lost my pen. Two minor arcs are congruent if and only if their corresponding chords are congruent. So you'll notice that this arc has the same points as this chord. This arc has the same points as this chord. So therefore, if the arcs are congruent, then the chords are congruent. If the arcs are congruent, then the chords are congruent. Take a minute, pause, write it down. Okay, next theorem. The perpendicular chord bisector theorem. It's wordy to say that if you have the diameter, so it goes through the center. Remember the diameter is a chord that goes through the center. It's a very specific kind of chord. It goes through the center. It splits your circle in half, so to speak. Okay, so if you have a diameter, okay, and it's perpendicular to a chord, so that diameter and that chord make right angles. I keep scribbling and now you can't see. So if this chord and this diameter are perpendicular, then it means that the diameter bisects the chord, which means that this is congruent to this. Remember, bisect means it gives us two congruent parts. Pause, write it down. This is the third that we're going to use right now. Okay, so it's the converse, so backwards from the one we just talked about. So if you have a chord that is bisected, so this part of the chord and this part of the chord are congruent, and it makes a right angle with whatever this chord is, then it means that this chord is a diameter. I will say all that again for you with it. Okay, so pause and write it down. And then, so it's backwards. So if you have two chords that intersect, and this chord has two perpendicular parts, and the two chords are perpendicular, then that chord is a diameter. Pause, write it down, I'll move it on. So let's see what all that means to us. Okay, so you got to pay attention to what the words, because sometimes the words, especially in this book, sometimes the words are already written. So it says that FG is congruent to JK, right? FG is congruent to JK. Well, it says it, and they wrote it on there by putting the little marks for you. Okay, But sometimes they don't write it on the figure for you. So so pay attention to that, okay? That just read the actual, don't just look at the picture, read the actual words and make sure that, okay, so FG is congruent to JK, got it. Measure of arc JK, that M means measure because it's a little m, okay? And notice the arc only goes over the J and the K. So the measure of JK is 120. Okay, that's Mark 2. We're good. Okay, so now we want to find the measure of arc FG. Okay, well, you might remember that if we have two congruent circles, which we do because the radius is congruent to the radius. The two radii are congruent, so therefore we have congruent circles. Okay, so, and it says we do anyway. So if our two circles are congruent, which they are, then our minor arcs are congruent if our chords are congruent. Okay, that was the first one that we talked about. So if this arc is 120, then this arc is 120. There is a lot of stuff going on in this problem. I just thought I'd point that out from the beginning. Okay, so here we have JL that runs through the center, so it must be a diameter. Okay, we have HK, which doesn't run through the center, so it's a chord. So remember in our theorem post, we had like this chord up here in our diameter, right? But it's the same idea. Our chord's just down here this time instead. Okay, so before you even read don't even read the questions yet. Okay, just think about what we've got going on here. So we've got the things are perpendicular. Okay, so if our chord is perpendicular to our diameter, then it means that the diameter bisects our chord. So that means that this is going to be equal to this. Yes? So that would mean that if NK is 14, then HN must also be 14. I'm pausing. I hope that makes sense. Okay? So let's go back over here to our questions now. Okay? So what that means is that if we want to find KH, well, KH, that's that chord right there, right? Well, we know that this half is 14 and this half is 14, so the whole thing must be 28. Be careful what it's asking for, because sometimes it'll ask for the whole thing, sometimes it'll ask for just part of it. Okay. I'm actually going to erase those scribbles because we're moving on to a different thing now. So here we want to figure out the measure of HLK. So HLK. Okay. I'm guessing that this and this have something to do with that, right? So let's see here. If we know that this arc goes with this arc, right? The perpendicular chord bisector theorem, that mouthful, tells us that this diameter is not only bisecting this chord, but it means it's also bisecting this arc here. So what that means is that this is equal to this. So 2x minus 8 equals 127 minus x. So let's see here. Let's add the x. 3x minus 8 equals 127. Add the 8. 3x equals 135. And x equals 45. But it doesn't want to know what x equals, right? We want to know what's this measure. Okay, well, let's see. If we put that 45 back in, so it's probably easier to put it in there. So 127 minus 45, oh, let me grab my calculator. 127 minus 45 gives us 82. So that means that this arc is 82, this arc is 82. So 82 plus 82 gives us 164. Well, again, what does the whole circle equal? 360. So let's do 360 minus 164. I'm going to use my calculator again. Oops, I put 161 anyway. So that gives us 196. So the answer to the measure of HLK would be 196 degrees. Okay, so moving on, and you're not going to like these very much, but that's okay. We are not going to be exact. We are not going to get out rulers and protractors and compasses. We are going to estimate. When you do these problems, I think there's only one in your assignment. I need to see your work. I need to see your little drawings. They may not be perfect, but I need to see them. So, I left this one up with the whole solution, so you can pause and read it and write it and work it out. But so here's the thing. We have these 3 garden bushes, okay? And we want to figure out where a sprinkler should go that would hit each of them equally. So in our solution here's what happened is we drew these are the 3 bushes here, A, B, and C. We just drew them out without all the grass and bush pictures and stuff, okay? So what we need to do is we need to take and we need to figure out where halfway between is. Oops. Okay, and then we're going to draw perpendicular bisectors. So you want that to be perpendicular-ish. Okay, and there, where those 2 lines meet, is where you'd want to put your sprinkler. So here's an example without the answers. So a telephone company plans to install a cell tower. So here's the centers of the towns, apparently, and we want to figure out where the cell tower would be placed. Okay, so draw yourself connectors, if you will. Now, what would happen if you did these connectors? You'd get the same answer. It doesn't matter. Okay, my head, it makes more sense if I do these 2. I don't know why. So find your halfway or so. Just estimate. I don't want you to be, you don't need to be exact. I know that you know how to use a ruler. Okay, so there's our bisectors. So then let's draw fairly straight-ish lines perpendicular to those bisectors, and that is where you'd want to put your cell tower. Look, we have another theorem. I told you this was a long one, right? So the equidistant chords theorem. Here's where we start to get kind of complicated, okay? Now, you have the advantage that when you're doing these assignments, you can be using your notes. So make sure you take good notes and that you have all these theorems, maybe even have a separate sheet with all the rules and what's equal and all that good stuff, okay? So here's what this one says. The 2 chords, I'm going to change up my colors to make this fun. The 2 chords here and here, those are our 2 chords because they go to the edges of the circle, right? Are equal or congruent if they're the same distance to the center. So obviously from here to here is not the same as from here to here. So you would also need to, so you need to make sure the point on the chord is the same like distance from this point too, so to speak, okay? But when you get the pictures of them, they will be. Okay, so pause, write this down. I'm going to say all of that again. So this chord and this chord will be equal if they are the same distance from the center. Okay? The reason we've got the right angle boxes there is because that tells us that this the F is the same distance from A that G is from C. Okay? So let's see what all this means. Pause, write it down if you need to. What I meant was pause it if you need to. Definitely write this down. Okay, so there's a lot going on here. Okay, so EP is equal to EQ and they both equal 12. Okay, that's on there. EP, EQ, they both equal 12. Got it. Okay. CD. Oh, wait, no, not arc CD, is it? It's just segment CD or chord CD is 5x plus 7. And AB is 7x minus 3. Okay, that's all on there. Good. We want to find the radius of circle E. Join me now and say, what now? So take a break if you need to, because this one's going to hurt our brains, but we can do this. Okay, there's just lots of steps. It's not a big deal. It's not anything really new. We're really just going to use the stuff we know about right triangles. We just have to make a right triangle first. So let me go back. Let me use these colors. So if we make a right triangle here, EC is a radius, right? So that's what we're trying to figure out, the radius. Okay, well look, now we have a right triangle. We know stuff. We can do stuff now. We got this. Okay, so first we need to figure out what this side equals, because we know this is 12 and we know this is x, so we need to have an actual number here. Right now all we have is 5x plus 7. Now technically we could put x squared equals 5x plus 7 squared plus 12 squared into Pythagorean theorem just like that, but I really don't want to do that math and we don't need to. Okay, so don't do that. We don't have to do that much. We don't have to do that hard of work. Okay. So okay, I'm switching colors again. So we have this guy over here to help us out. Okay, we know that BP. Okay, so we can set 7x minus 3 equals 5x plus 7. Okay, let me back up and just remind you that the 5x plus 7 is this, the 7x minus 3 is this whole thing, and we know that those chords are equal because of that very first theorem we learned today, that if these parts are equal and perpendicular, then the chords are equal. Okay, try to get rid of some of my scribbles maybe. So actually I'm gonna do this. So remember that that's the whole thing. Okay, and so when we solve that, we end up with that x equals 5. Okay, you can solve for x. I know you know how. So what that means is that again, we're trying to figure out this, right? The CQ, right? Well, if we put the 5 back in, we get 32. And that is actually the whole thing, right? So to find CQ, we need to cut the 32 in half. So CQ is actually 16. So what that means is that we now have, let me just redraw this. We now have this right triangle that we know two sides, and we're looking for the hypotenuse. So we can put it all into Pythagorean theorem, and do 16 squared plus 12 squared equals x squared. Of course, this is our hypotenuse across from our right angle, so that's why it is out here as x squared. So when we do that, 16 squared plus 12 squared, we end up with 400 equals x squared. Take the square root of both sides, and 20 equals x. And that was a very long, drawn-out method to figure out the radius of circle E. I don't think I have, oh, I do have another one of those. Okay, good. Let's do this. So, in this case, we're still trying to find the radius of n, right? And we know that JK and LM are equal, and they both equal 24. Okay? Well, let's see here. So that whole thing is 24, and that whole, I'm not going to write it in there because it's hard to, it would be clutter things up. Okay? In P is 3x, what's written on there, good. And in Q, that little bit right there is 7x minus 12. Okay? So we need to figure out where might be the best place to draw a radius that is going to kind of make sense to us. Okay? Well, let's draw from N to K. Okay, and we're trying to find the radius. Let's call it R this time because we have so many x's and stuff in there. Okay? Because we know if JK is 24, right, and we've got the diameter hitting it perpendicular, then that means that PK here must be 12. Okay? So we are almost there. We're getting so close. Now, they've given us this 7x minus 12 and this 3x, okay? Those are our pieces that would be congruent because they're equidistant to the chords, okay? Don't let this NT over here throw you off, okay? So that means that we know that 3x is equal to 7x minus 12. And when we solve, that would mean that 12 is equal to 4x and x equals 3. Okay, that's exciting. Well, we need that to go in there, right? Into that 3x. 3 times 3 is 9. So that means we have this triangle that looks kind of like this, P in K. That's 12, the one we're looking for, and now 9. So we can do our Pythagorean theorem. Notice that we are still looking for our hypotenuse. So we can do 9 squared plus 12 squared equals r squared. Okay, some of you might notice this is a Pythagorean triple. Okay, so I know what the answer is going to be, but that's okay if you don't. So 9 squared is 81. Plus 144 is equal to r squared. That would be 225. Again, I know what the answer is, but let me just double check on my calculator over here. 81 plus 144. Oh yeah, it is 225. Good. Equals r squared. Take the square root of both and turn your calculator to the side, and the square root of I don't know what I did over there. Square root of 225 is, in fact, 15. So, 15 is our answer. 9 is a triple of, is a multiple of 3. 12 is a multiple, so like 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. That's how I knew that it was going to be 15. So this is probably the hardest part of this section. Just work at it. You can do it. Rewatch the video. Ask questions if you have them. I'm pretty sure that's all I have, so here is your assignment. Have a great day.